Hello again, everyone, and welcome to another Sun Devil Learning Labs lesson from Arizona State University. I'm your instructor, Michael Parker, and today we're going to relate decimal and fraction multiplication. We're going to work with fractions and decimals and see how they are the same and how we can translate one to the other. And sometimes it'll be easier to work with fractions, and sometimes it might be easier to solve our problem by working with decimals. But by doing that, we need to get some practice and find some common things out that we do know about decimals and reinforce what we already know about fractions. So before we start doing that, I'd like to remind you, as we usually do, three things that I always try to go over. First, I want you to make sure that you're in a comfortable setting with no distractions, no siblings or pets or anybody running around making noise. The TV shouldn't be on, there shouldn't be any music. Nothing that can keep you from finishing your lesson in a timely manner. The more you stall and the more you get distracted, it'll probably take you a longer time. Second, gather any supplies you might need today. I suggest a couple of pencils, a notebook, and if you're not keeping a notebook, at least several sheets of paper to work on. Scissors are sometimes helpful, and a ruler is real helpful for drawing models. Third, be sure and use the restroom before we start. You don't have to get up right away and go then. And remember, you can always pause the video if you need to take a break. If you do get distracted, or if you have trouble and need to go back and review something, just pause the video and you can creep back to wherever you needed to take a look at it. I've got this little notation pad above myself here as well. And if you see that, it's just a reminder that something we're doing may be worth taking notes about. And if you are keeping a notebook, I would definitely add that information to the notebook. So now let's get started with a little bit of review. Here's a little fluency review. And I've written word sentences, and I'd like you to take a minute or two and write the number sentence with the solution. 1/2 of 1/4, 3/4 of 1/2, and so on. It shouldn't take you very long, and when you come back, I'll show you what I think the worksheet should look like. Welcome back. Hopefully you came up with something like this. 1/2 of 1/4, 1/2 times 1/4 is equivalent to 1/8. 3/4 of 1/2, 3/4 multiplied by 1/2. 3 times 1 is 3. 4 times 2 is 8. Another one straightforward. Over here, 1/3 of 4/5. You should have got 4/15. 2/3 of 1/3. Your answer should be 2/9. And 2/5 of 2/3. Again, 4/15. Nothing really too tricky or complicated about any of this multiplication. Now we're going to move on to converting fractions to decimals. You've learned a lot of this before, but some of this may be refreshment. So take your time, and in a few minutes we'll come back and I'll show you how I think your answer sheet should look, and hopefully yours resembles it. All right, welcome back. Hopefully we'll go through this kind of quick. 1/10, 0.1 is how we read that. 2/10, 0.2, and I hope you see a pattern here. 8/10, 0.8. Now we move over to 1/100th, 0.01. 9/100ths, 0.09. I hope you're seeing the pattern again. 15/100ths, 0.15. 93/100ths, 93 parts of 100. And then we went back to tenths just to see if you were paying attention. 7/10, 0.7. So hopefully your answer sheet looks like that. If not, take a minute and go back over it and maybe see where you made your mistakes and look at some of the similar problems to compare with. Another part. Now we're going to work on multiplying whole numbers by decimals. It's a little more of your fluency work. Again, it's a little bit of review, and it's going to help prep you for some of our lesson as we go forward. Okay, hopefully that didn't take you very long. Again, most of it should be straightforward. You can see the pattern here. 2 times 1/10, basically what we did with fractions, but now we're working with decimals. 0.2, 2/10. 3 multiplied by 1/10, 0.3. 7 times 0.1 is 0.7. Then when we get down to our hundredths, nothing really changes. 5/100ths is written 0.05. And then when we start getting into larger units, 20 multiplied by 1/10, you should have gotten 2.0. 20 multiplied by 100th, 0.2. We can do the same thing with 30 and 53, even though our ones are different, it's 53 multiplied by 1/10, 5.3. 53 multiplied by 100th, 0.53, and 37 should look the same way. You should have had 3.7 and 0.37. So now let's look at an application problem for today's lesson. Ms. Casey grades 4 tests during her lunch. She grades 1/3 of the remainder after school. And if she still has 16 tests to grade after that, how many total tests are there? Now, a little bit of this is review, and it's just going to help get us thinking towards the next part of our lesson. So let's work on this. It's not really, it's a sort of word problem where it probably helps if we use a tape diagram. The problem is we don't know our total, right? That is our question. How many total tests are there? But we do have some information. So let's break it up into parts. There's going to be our whole. And then let's look at what else we do know. We know she grades 1/3 of the remainder. So let's draw another tape diagram, create the remainder. This should all be pretty much old hat to you by now. And 1/3, we're going to mark off, we'll break it into a 1/3 unit. And we know that that's what she graded after school. And then she still has 16 tests to grade after that. And that goes in the other part of the remainder because she hasn't graded those 16. And we're already trying to count the 1/3. Let's see how that would look going forward. Hopefully, we can do something where we recognize that our remainder unit can be divided into 3 equal parts, 1, 2, 3, each 1/3, which means if these 2 equal parts are half of 16, that would give us 8 and 8. We now know that 1/3 of the remainder is equivalent to 8, right? So we know 3 multiplied 8 times, which would give us 24. So we know the whole remainder was equivalent to 24. But we also got to remember, Mrs. Casey graded 4 tests during her lunch. So we have to add that to the rest of the remainder that we already calculated. 24, the remainder, plus the 4 before lunch, should give us a total of 28 tests, total tests graded. And now let's move on to our first problem that I'm going to work with you together. We want to know what is 1/10 of 4, or 0.1 times 4. We can multiply and we get 1/10 multiplied by 4 is equivalent to 4/10. And we could write that also as 0.4. I want to emphasize here, we do not simplify our fraction when it's in tenths. It will not work on our place value chart, and it'll make it a lot more difficult to to convert to these decimals or change decimals when we want to multiply. So in this situation and the rest of our work, if we wind up with our units in tenths, hundredths, thousandths, we don't want to simplify our fractions. We'll work on just expressing our answer in decimal form. So we can look and we realize that 1/10 of 4 is equivalent to 4/10, but written as a decimal is 0.4. And now if we want to look at that on the tape diagram, or not the tape diagram, I'm sorry, but our place value chart, I'll move out of the way here for us. We saw we had 4, and we wanted to know what 1/10 of that was. So when we multiply by 1/10, reviewing now, we should just move our decimal one place to the right and our value one place, and it becomes 4/10. 1/10 times 4 would move us to 4/10 because we're multiplying by the smaller fraction, the smaller unit. I can show you here as well. 4 times 0.1 equals 0.4, and 4 times 0.1, 0.4. It's the same problem, and this is the same thing. 4 times 0.1, or 1/10, is going to be equivalent to 0.4. Let's look at something else. We're going to try it now with 6, but this time we're going to look at 6 times 1/100th. So what do we know about that? Our unit is 6. We can put it right in our place value chart. And what else do we know? Well, we know that we're going to multiply by 100 this time. So where is our 6 going to need to move to? It's going to need to move to the 100ths column. Our decimal is always going to stay in the same row. So 0, our decimal, our 6 times 1/100th becomes 0.06. I didn't write the first 0 in, but it's this side of the decimal, 0.6. And finally, we're going to do the problem one more time, but let's look at it with ninths. 9 times 1/1000th. Again, 9 times 0.001, equivalent to 0.009. And what do we know? We know we started with 9 units. We want to multiply by 1,000th. So what are we going to do? We're going to move our unit 3 places this time. 1, 2, 3. But our decimal is going to stay in the same row. So our solution is 0.009. And that is what we wound up with on when we did it numerically, as well as when we did it on the place value chart. So let's look at another problem. We're going to move forward here, and I'm going to ask you to take a look at this for a minute and tell me what you think. You can already see that I've used an area model, but take a minute and see where you would go with this problem and if you agree with how I think we should solve it. It's 0.1, 1/10, times 0.1, 1/10. 1/10 of 1/10. Okay, now that you've taken a few minutes, I hope you can recognize 1/10 of 1/10 is going to be equivalent to 1/100th. We can verify that with our area model. 1/10 we've drawn 100 squares, and here's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 in this first column. But we want to know what 1/10 of this is. So 1 out of these 10 would be in this column. So we wound up with 1 square shaded out of 100 total squares. So 1/10 of 1/10 can be represented in our model by just 1 small square. And that is exactly what you see. 1/100th of is a small part of our entire model. Hopefully you'll also start to recognize that using this area model can be a little bit difficult at times, because what happens is, and you'll see as we go look at another problem, that the pieces can get really small. But before we do that, let's solve another problem here where we're looking at 2/10 of 1/10. Hopefully that should be fairly simple to you as well, because now we're going to count 1, 2, 1/10, 2/10 of 1/10. And what did that give us? Now we've shaded 2 squares out of our total of 100. So 2/10 of 1/10, that should be recognized as equivalent to 2/100ths. Okay, let's move forward a little more. We can look at this on our place value chart and see that maybe this is easier than drawing an area model. We know that we're starting with 1/10, and we want to know what 1/10 of that is. We're going to multiply by 1/10. So what do we know when that happens? We're going to move our units to the right, one place. Decimal stays the same. So where we move from, we need to replace it with a 0. So 1/10 of 1/10 is 0.01. And our second part of that problem, when we did 2/10 of 1/10, we can also look at that. I did it in blue instead of yellow to make it a little more clear for you. But 0.2 2/10 becomes 0.02. Both values move one place to the right as we multiply by 1/10. That's where the place chart really comes in handy when our units are written in terms of tenths, hundredths, thousands, or our unit, tens, hundreds, thousands, and so forth. We won't get into our higher values yet, but I hope you can see the value of using our place value chart. Okay, let's try another problem. Now this time, we're going to use a whole number mixed with a decimal, and it's going to be 1.2 times 1/10. If we do it mathematically, we can recognize that our solution will be 0.12. We also can convert it to a fraction because we know this 1.2 is the same equivalence as 12/10 multiplied by 1/10, or 12/10 of 1/10, will be equivalent. Numerator, 12 times 1 is 12. 10 multiplied by 10 is going to be, oh, I wrote that wrong. That should be 100th. I hope you'll forgive me. There should be another 0 here. And we can see it on our place value chart, though, that 1.2, 1 and 2/10, when we multiply it by 10, we can move, our 1 moves from the unit place to the 10th place, and our 2 is going to move from the tenths to the hundredths. So our solution is represented by an answer of 12/100th, as we wrote up here, where I multiplied without using the conversion to fractions. Now I want you to think about our place value, our area model that we used earlier. And I want to ask you, we have our 1/100th, we know that. What would 1/10 of 1/100th look like in this diagram? It would be basically asking you to break this 1 square into 10 equal parts. I think you can see that that's going to be pretty tricky and not really a good way to work, and it's just going to be too hard to be that detailed and accurate. So what do? We can solve it with our place value chart, right? We know that 1/10 of 1/100th is a very simple problem. We're going to start with 1/100th, right? 0.01 is represented here, and that is 1/100th. Now we want to know what 1/10 of that is, and we know when we multiply something by the 10th on our place value chart, we're going to move our units. Everything's going to move 1 unit to the right. 1 will move 1. 0 is going to move, and our original 0 moves. So what do we wind up with? We wind up with 0.001. Our solution is 1/1000th. And I did it mathematically over here numerically, and it's 1/10 times 1/100th is equivalent to 1 times 1, and 10 times 100 is 1,000. I wrote the fraction the right way this time for you. And again, I hope you can see that this is 1/1000th. Let's try one more. We're going to look at 7 times 0.2, or 7 times 2/10. What do we recognize right away? Well, we can change it into fractions because it's going to be too hard to just multiply 7 times 0.2. But we know that 7 over 1 is the same as 7, and we're multiplying by 2/10. So what do we get? 7 times 2 is 14. 1 times 10 is 10. We now know that we're working with 14/10. And what do you think we're going to do to work with that? That's right. Here we go to our multiplication chart. Hopefully you can see that we can write this fraction quite easily in terms of tenths because we know how many tenths we have. 14/10 is going to be written as, we have what, 1 unit of 10/10. That's our unit number. And then we have 4/10 remaining. So 1.4 is our solution to writing 14/10 on our place value chart. And then our solution can be written as 1 4/10 or 1.4. Okay, now it's your turn. I'm going to practice some of what we worked. I've used the area model and your place value chart as needed. And if you're comfortable enough and you don't need both, that's fine. I'm going to come back in a few minutes and we'll work on the solutions that I did. I think I did them all both ways so that you'll be able to see what we did. And we also have a second page, problems. We're also going to do these again. Here's your place value chart and here's your additional problems. Let's do the whole set and then you can always come back. I'll go through the solutions for our first sheet first and then I'll come back here. But if you need to print or make a copy of your place value chart, you're going to take some time and do that because it does come in handy. I think you'll find you're going to use the place value chart a lot more than you'll use the area model. The area model is just not going to be very practical other than to illustrate how we're thinking. And again, you'll notice that you could probably work, if you draw your place value chart in such a way that you have numerous columns, you can see how I did some of your earlier problems. You can do more than one problem on the same chart. You don't have to maybe print one for every problem. So take a few minutes, and then when you're ready, we'll come on back and we'll go over the solutions. Okay? I would say this is probably going to take you maybe 12 minutes or so, maybe even a few more. Take your time. Again, that's the beauty of the video. You can work on it as long as you want and pause and go back and do whatever you need to come up with your solutions. Okay, welcome back. We'll go over the solutions. I hope it wasn't too painful for you. Our first problem, 4/10 of 3/10, or 4/10 times 3/10. I wrote it on my board as 4/10 times 3/10. And at first I did the math. 3/4, 3 times 4 in the numerator gave me 12, and 10 times 10 gave me 100. I saw the solution was 12/100. Now this is one we could have solved two separate ways. You could use an area model. I drew an area model on my whiteboard, so it's not entirely precise, but I think you can see what I was doing. First, I shaded in 4/10. 1, 2, 3, 4. And then I marked off the other side at 3/10. 1, 2, 3. And I shaded in all of our overlapping area. And then all I had to do would be count the units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it matches what we did when we did it numerically. Now we can also note that when we write that, all we have to do is write it on our tape model as in 0 point, there's our decimal, 1, 2, tenths and hundredths. And hopefully your solution looked a little bit like that. Let's move on to the next one. 1/10 of 1/4. So 1/10 of 1/4 is 1/10 times 1/4, or 1/10 times 14/10. Now that can get a little unwieldy for how we wanted to color those in. You could have colored 14 and multiplied them by 1, but I think it's just much easier, and I hope you see it and agree with me as well, that it's so much easier to use our place value model. We start with our units, 1.4, 1 and 4/10. And what do? We're multiplying by a tenth, so we know we're moving everything one place to the right. Our 4 moves into the hundredth place. Our 1 moves into the tenths column. Our decimal always stays in the same column. And we wind up with a solution of 0.14. So there's several ways to do it. We know what the fraction looks like, and hopefully you can just write the fraction, and your fraction should look like 0.14. Let's take a look at one more. 6/10 multiplied by 1/7. Again, I stayed away from the area model. I hope you see that that's really not worth the trouble sometimes. It helps sometimes, but I think the larger numbers, you're going to find that it doesn't work quite so well. But now here's 16/10 times 1.7, or 16/10 of 1.7 units, is the same as 6/10 multiplied by 17/10. And what do we see there? We wind up with a total of 102 100ths. Now there's really no way to get around changing this to a fraction and multiplying it based on how we're doing the problems now. But we do know now that how we want to write this as a decimal is probably a little bit easier to figure out on our place value chart. We know our units, 1, because we have a little more than 100, but we know our unit is 1. And then our tenths, 0, and 200ths. So we can write our solution as 1.02. Hopefully your answers looked a little something like this. And now let's move forward to another problem. 6 multiplied by 0.3, or 6 parts of 3/10. 6 multiplied times 0.3, we change it into fractions. Let's do that. Hopefully you have something that looks like 6 over 1 multiplied by 3 over 10, 3/10. And 3 times 6, 18. Denominator 1 times 10 is 10. You should have wound up with 18/10, the equivalent of 1.8, and you would write it on your tape diagram this way. It's a little too hard because we're not multiplying by tenths. We can write it in a tape diagram, but we can't really move it because we didn't write this. Remember, the tape diagram, place value chart, only works best, or only works at all, when our units are expressed in tenths. We have to remember that. We should make a note that we have to have our units in tenths, and that's why I said earlier, do not simplify. Second problem, 1.2 multiplied by 4, or 1 and 2/10 of 4. 12/10 multiplied by 4 over 1. We wind up with 48/10. And we know that that's going to become, we can write that in our chart if that wants to help us here, because 48/10, we know we have 4 decimal 8/10. So it does help us to find our places that way, because we know where our units are and where our decimals should be. So when we write 48/10, we could come right over here and we know that that's 8, and we could put in the 4, and that's another way to utilize the place value chart in addition to just doing the straight multiplication of the fractions. One more time, 0.6 of 0.3, 6/10 of 3/10. 3 times 6 will give us 18 units. 10 times 10 will give us 100 units. We probably could have used the area model, but I think you can see this is fairly simple. And now when we want to write 18/100ths, we just go to our place value chart. We have no units. We have 1/10 and 8/100ths. So our solution again, 0.18, 18/100ths. Again, I hope your worksheet looks something like this. If not, maybe you can take a picture and or go back and see where you maybe made your mistakes. Okay, the next part of the problems. Now we're working with a whole number a couple of times, and we're going to ask 1.5 of 3, or 1.5 multiplied by 3. So what do we know 1.5 is? 15 tenths. What do we know 3 is? Well, it's 3 over 1. So how does that work for us? Multiply our numerators. 15 by 3 is 45. 10 by 1 is going to give us 10. And so where does that leave us? Well, we have 45 tenths. Now we know that that's going to be 4.5, or I think you can recognize that. But if we didn't, we could write 45 tenths in our place value chart. We know our unit is going to be 4. We know our 5 is going to be for the tenths because we have 45 tenths. So 4.5 is another way to arrive at our solution. Let's look at the second part of that problem. Now we have 1.5 again, but this time we're asking what part is 1.5 of 3 tenths? So it's a little bit different problem. 1.5 is still 15 tenths, and we're going to ask what part of 3 tenths is that? 3 tenths. Well, let's multiply again. 3/15. 3 times 15 is 45 again, but this time 10 times 10 gives us 100. So now we're looking at 45 100ths, and how would we express 45 100ths? Well, we can go to the place value chart, and what do we come up with? Well, we have no unit parts this time because our 5 is our 100th, and our 4 is our 10th. 45, we've moved that over here. So the way we would write our solution is 0.45, the equivalent of 45 100ths. And one last problem that we have to finish up. 0.15 multiplied by 0.3, or 15 hundredths of 3 tenths. 15 hundredths multiplied by 3 tenths. Now 3 times 15 is 45. 100 times 10 is 1,000. So now how are we going to write our solution? Well, we have to go back to our tape model, or our place value chart. And what is 1/1000th? Well, our 5 is now going to be in the 1,000th place. Our 4 will be our hundredths, and we have 0.045. 45 1,000ths is our solution, and this is our place value chart tells us how to write that. Hopefully your worksheet looks something like this. If not, we're going to have a chance to review it a little more as we proceed through coming lessons. That's about it for today. I hope you had success with the practice problems, and if not, you can always visit Khan Academy, and we have other resources on the Sun Devil Learning Lab site as well. Thanks, and have a good day.